Hello world, Noah here, and welcome to a Lesson 3 aside. In this video, I'm going to be talking about the math and random modules. Now, this is optional material, and so if you would like to skip it, you can. If you find it to be too confusing at this point, you can skip it and come back to it. But for those of you that are looking to do a little bit more math-related stuff with Python, perhaps you'll find this video useful, and hopefully it won't be too tricky. So I'm not going to sort of explain too much about what's going on. I'm just going to demonstrate it because in order to explain it, there's quite a bit more about Python that you have to know. But essentially, a module is a collection of code that someone else already wrote that you can use. And so Python, the developers of Python have written, among many other modules, they've written two modules, the math module and the random module. The math module provides some math-related functionality that you can add to your code, and of course the random module provides some random stuff, generating random numbers, random samples, etc., etc. I'm just going to show you some of the things that you can do with these modules. I'm not going to talk too much about how they work. But let's start with the math module. So in order to use a module, the important thing that you need to do is you need to write at the top of your code, import math, or import and then whatever the name of the module is. So in this case, using the math module, we say import math. This lets Python know that we want to access some of the data, some of the functionality of the math module. And so Python will load that in and we can use it. I would also recommend if you run this line of code, this help line right here, if you run that in idle, if you go into the interactive mode and you run that line, it will show you all of the functions, all of the things that you can do with the math module. And I'm going to show you a couple of them here, but there's more that you can do, and you can read through there to get some documentation, what's available, what functions are available, how do the functions work, what kind of data do you give it, what kind of data do you get back, etc., etc. So if there's some sort of functionality that you need that is not covered in this video, I recommend checking there to see, because maybe you'll find what you're looking for. So here are some of the most useful or the most, mostly used functions in the math module. The first one that I have here is math.sqrt, and so essentially you put some number in there where x is, and it will give you the square root of that number. And the output that it gives you will always be a floating point number. So for example, if I did, well, I guess it's not square root. The important thing is that you have to write, let me make this a little bit smaller, is that you have to write math.sqrt. You can't just write sqrt, you write math.sqrt, so Python knows that you're talking about the square root function that's in the math module. And again, don't worry too much about that, just know that you have to write math dot when you're using something in the math module. So for example, math.sqrt of 16 will give me 4.0. It's always going to give you a floating point number, even if it happens to divide evenly, but that's basically how it works. And then of course, if I did something like math.sqrt of 2, it would give me 1.41 ... and it'll be pretty accurate. It'll have a decent number of decimal places, so it should work for what you're looking for. And so if you want to take the square root of a number, that is the easiest way to go about doing that. Next is math.factorial. So you pass some number in there, x, and it will give you x factorial. If you don't know what factorial is, for example, 3 factorial is 3 times 2 times 1, and 4 factorial is 4 times 3 times 2 times 1. So x factorial is x times x minus 1 times x minus 2, all the way down to 3 times 2 times 1. And it's useful in statistics, it's useful in other places as well. And so, for example, if I do math.factorial of 4, it would do the calculation essentially 4 times 3 times 2 times 1, which is 24. It will always give you back an integer, and it will always require you to give it an integer. So if I did math.factorial of 4.5, it would give an error message because it's not defined. The factorial is only defined for whole numbers, for integers, and it will always give you back an integer. So that's all for math.factorial. Does exactly what it says it does. It's a pretty efficient implementation. So if you need factorial, I'd recommend using math.factorial unless you're writing the function yourself for educational purposes. Otherwise, the built-in one is great. Then we have these two, math.ceil and math.floor, and they basically work together. They do sort of the opposite of each other, but essentially math.ceil will round numbers up, and math.floor will round numbers down. And so you pass each of these functions, this x can be an integer, it can be a floating point number, it doesn't matter, but you're always going to get back an integer because the functions will round the number up or down to the nearest integer. So for example, if I do math.ceil of 2.7, the ceiling function says to round up to the nearest integer. So 2.7 is going to round up to 3. But you'll also notice if I do math.ceil of 2.0001, it's also going to round up to 3, right? So basically the idea there is that if there's anything after the decimal place, you're going to round up. And if there's not, then you're going to stay where you are. So if I just do, for example, math.ceil of 2, it's going to give me 2, right? Because 2, there's nowhere to round. I'm already at a whole number. So basically, if there's something after the decimal place, it doesn't matter how small it is, you're going to round up to the next integer. If there's no decimal place, if it's 2 or if it's 2.0, you're going to stay where you are. And then floor works in the opposite way. So math.floor, for example, if I do math.floor of 2.7, it's going to give me 2. And if I do math.floor of 2.001, it's of course going to give me 2. And if I do math.floor of 2, it's going to give me 2. And so what you'll notice is even though 2.7 would normally be rounded up to 3 in our conventional math, when we say floor, we always want to round down. And so one thing that I will point out really quickly is if I do, for example, we can go back to our integer division, and if I do one integer divide by 2, that would give me 0, right? One integer divide 2, it's 0 and remainder 1, but we don't care about the remainder here. This is basically the same thing as doing math.floor of 1 regular divide by 2, right? Because 1 over 2 with regular division would give 0.5, and then the floor function would round it down to 0. So basically the integer divide function, or the integer divide operator rather, will basically do regular division and math.floor. It won't actually do that, but you can sort of think about it as doing both of those steps together. So those two statements are equivalent, but the integer division is obviously much quicker to write. It's less code. And the last thing I'll show you really quick is there are two constants, or at least here are two constants that are in the math module, math.pi and math.e. They'll both give you, approximate values for pi and e. Of course, they're not exact because pi and e have infinitely many digits, but if you do math.pi, you'll get an approximation with a good number of decimal places that will be more than adequate for any calculations that you're trying to do. There's no parentheses, it's just math.pi, not math.pi parentheses, because these are constants. They're not functions, they don't do something, they're just numbers. They're just essentially like variables. And again, this may be a little bit confusing, the syntax, but don't worry too much about the syntax and about how it's working because that's a little bit beyond what we know at the moment. But for example, if I wanted to use math.pi to compute the radius, I could do something like math.pi times, or not to compute the radius, but math.pi times 2 times radius. If I were doing some calculations, that would be 2 pi r, right, which is the circumference of a circle. You could do pi r squared, how to do square, which is 2 asterisks, etc., etc. So you can use pi and e, these constants in your code if you're doing something that would use them. You could also just declare your own pi and e variables if you wanted, but these are pretty pretty accurate. They have a good number of decimal places, and so I'd recommend using them. So let's just take a quick look at the random module now. We're only going to talk about one function at the moment. There are some other functions in there that are going to be useful, and I'm going to do another aside in a future lesson where we look at them, because the future ones have to do with lists of values, and we haven't gotten to lists yet. But again, in order to use the random module, you need to import it. So you want to write import random at the top of your code, so that you can access the random module. And then if you do help random, it will show you all of the functions in the random module, and for each function, each thing that you can do with this module, it'll give you information. What data does it need? What does it give you back? What calculation does it do? Whatever. So you can look through there to see if you can find what you're looking for. But I'm just going to show you one function that you might find useful. It's the Rand Int function. So the Rand Int function takes two parameters. It takes two pieces of information. I called them A and B here. But they're essentially the lower and upper bounds, and it will give you a random integer between A and B inclusive. So for example, if I do random.randint and I do 1, 10, just like that. So random.randint 1, 10, this will give me a random integer, a random whole number between 1 and 10 inclusive, meaning that it could be 1, it could be 10, or it could be anything in the middle. So for example, if I ran math.randint one time, maybe it would give me back 4. If I ran it again, maybe it would give me back 6. Maybe it would give me 1. Maybe it would give me 10. Maybe I'd get 4 again, etc., etc. But it'll essentially generate a pseudo-random number, aka a random number that's good enough, for what we're doing, that's within this range. And so we'll actually end up using this function in a future project, and so maybe it'll make a little bit more sense. But if you want to introduce some element of randomness into your code, you can use this function to generate a random number within a range that you're looking for. And so that's all for this aside. I just wanted to point out these modules that you can use and these functions that you can use if you're looking to do some sort of calculations in your Python code. Some of these functions might be useful to you. But again, if this was confusing or if you don't quite see the point yet, then don't worry about it, because it'll all become more clear later. Yes, that's all for this aside. Hopefully that all makes sense, and I'll see you guys in the next one. Bye for now.